In this last video of state transformers, this is we're still on state transformers, and what we're going to do in this video is we're finally going to use our state transformer, and we're going to make it an instance of the monad trans type class. Okay, so again, in what we had so far was we had this new type definition. We had this new type definition where we had this wrapper. We had this wrapper over here, which was basically a wrapper around this type signature. And what we're going to do is let's just write the type class definition for the monad trans. So I have class monad trans T, where I have where I have the lift method and the type signature for the lift method is as follows. It takes in a monadic value MA, and it gives you back as an output a lifted version of that value, which is surrounded with wrapped in this type variable T. So I have TMA as my output. Okay. Now, one of the things that we saw, at least from my last video on list transformers, we were able to figure out the kind for this T here. So the kind for T is a T is something that consumes in the kind for M, which has the following kind, and the kind for A is a concrete type, giving you back as an output another concrete type. So the kind for T then is that it takes in these two parameters, okay, which is my M and my A, and it gives you back as an output another concrete type. That's the signature. That's a kind signature for my T. And what I would like to do at this point is, using my new type definition for state T, I can then figure out the kind for A, M, and S. The kind for this A here is that it's a concrete type. The kind for S is also a concrete type, and the kind for M is a type constructor that goes from a concrete type to a concrete type. Okay, so what should I use to make how do I get my types matched up? How do I get my kinds matched up here? So what I need here at this point is state TSMA, so I can just partially apply them, and so let's do this. State T. Let's see, state T has the kind for concrete type, and then it takes in M, and then it takes in A, and it gives it back finally a concrete type there. And if I just partially apply this, meaning if I do state T and I just pass in S, the kind for state T of S is basically the following. Okay, and now if I look at the kind for state T of S, which is this piece here, and I look at the kind for T, they both completely match up. Meaning now that if I would like to create something, an instance of the monad trans, I must be making that T, in place of the T, I must be passing in state TS. Okay, because the kind for both of them match up. So if I make state TS an instance of the monad trans type class, I must then provide the implementation. To the lift method. So if I were to just replace everywhere I see a T there, I'm just going to replace that T with state T of S. So if I just rewrite the type signature for my lift as follows, if I write this as in place of T, I'm just going to write there state T S M A, and let's just provide the implementation. So again, I'm not going to write the boilerplate code creating an instance of the monad trans, but I'm assuming you already know that what I'm doing at this point is I'm making state TS an instance of the monad trans type class. So the implementation to the lift method then, the implementation to the lift method then is that lift then takes in some value, let's say some value in the variable x. The value in this x is going to have a type, of MA, right? And it's going to give you back as an output some value of type state T S M A. How do you create a value of type state T S M A? I can create that value by invoking the value constructor. So I'm going to invoke the value constructor state T, and in there, in turn, I'm going to pass in some value. I'm going to pass in some value that has the correct, it has this correct type signature. So, so I'm just going to say S. Okay, I'm just going to provide the S in the first place. Is this method that takes in as a first parameter some state S, and then it must give you back, this method should return back some monadic value, which is this piece over there. How do I get that monadic value out now? So what I really need is this A. I need this A separated, and this A currently is completely wrapped up, in this monad M. So I can use my do block here. And I can say that let's take this X, which is of type MA, and basically just using the nice clean form of the bind operator there. So I get out basically just the pure value devoid of any of the monad. So instead of calling the X, let's just make this XM, just so that we know that this is the monadic value XM, and this is also XM. And now that I get a devoid of the monad, this is going to be just X, just the pure value X there. Okay, so I got the pure value X now, and what I need is just to take this value X and put it in a tuple. So let's just create my tuple here. I will take this value X and pass in my state S there, whatever the state S at that point was. And finally, I'm just going to wrap it up again in my monadic value by passing in return to get this final M. Remember this, the entire piece in blue here, this entire piece in blue is a monadic value, and this is what I'm getting back, the monadic value at the entire point here. And now if I close the parentheses there, what I have now is the actual implementation to my lift method by making state TS a monad transformer.